Shubh Navabarsha, my dear students. Hope you all are taking all the safety measures to fight against COVID-19 coronavirus. You are staying at your home. Wash your hand properly and be safe. Let us start chapter 1 of chemistry, that is matter. Already we have provided some supportive videos and study materials on this chapter. Today we are going to learn few more topics from the same chapter. First of all, we will learn about diffusion. About diffusion you have learned in your previous class. It's nothing but intermixing of particles due to motion, and after this intermixing they will come to a uniform, they will form a uniform mixture. So to understand diffusion we can do a very simple experiment with bromine gas. Bromine gas, its color is reddish brown. So for this we have to take it in a beaker. We have to take it in a gas jar, and we will take another gas jar which is filled with air. So how we will do this? In gas jar A, we will take this bromine gas which is reddish brown in color. I cannot show the color here, but this is filled up with bromine. This is gas jar A. And on this gas jar we will keep another empty gas jar. Actually it's not empty, it's filled with air, but its color is, it's not having any color because air is colorless. So this contain air. This we can say as gas jar B. So if we keep it in this manner, after some time we will see this color of this both the gas jars, it will become light brown. That means bromine gas, after diffusion, it has been spread in both the gas jar B and A. So the particles or the molecules of bromine, it will spread all over in the gas jars A and B. So this process is called diffusion. Okay. Next, our next topic, that is we will do some experimental proof. We will do some experimental proof on law of conservation of mass. For this, experimental proof of law of conservation of mass. So for this we will take a conical flask and in this conical flask we will pour some solution of 5 ml solution of sodium sulfate, Na2SO4, and here we will keep a cork in the mouth of the conical flask, and through this we will hang our test tube filled with barium chloride solution, 5 ml of barium chloride solution. Now we will take the weight of this whole setup. Let's say the weight of this is W1. Now we will shake this conical flask so that the content of this test tube comes out and it will get mixed with the solution of sodium sulfate. So we will get, after some time, we will wait for suppose 10 minutes so that the reaction will be completed and we will get the product. So sodium sulfate, when it will react with barium chloride BaCl2, we will get sodium chloride NaCl and barium sulfate as a white precipitation. So we will wait till the precipitate will get settled down the bottom of the conical flask. So this is the balanced equation for this reaction. Now after the reaction ends, we will again weigh the whole setup. That means the conical flask along with the test tube and the cork, etc., and the string as well. Okay, so say the after the reaction, the weight of this setup will be W2. Now we can see W1 will be equals to W2. That means before the reaction of this sodium sulfate and barium chloride and after the reaction, that means after getting the product sodium chloride and barium sulfate, the total weight of the reactant, that is W1, will be equals to the total weight of the product, that is W2. So law of conservation of mass is confirmed. It's whole good. Another experiment we can do for the same to prove the law of conservation of mass, and that we will be doing with baking soda. This is experiment number 2, and for this we have to take baking soda, that is sodium bicarbonate, and acetic acid, commonly known as vinegar. It's CH3COOH. Now what we will do, we will take in a Ziploc bag, we will take some, suppose 1 cup of acetic acid, the solution. In this Ziploc bag we will be taking the solution of acetic acid, and in a piece of paper we will put some baking soda, sodium bicarbonate, and we will place it in the same Ziploc bag, and immediately we will close the zip. Now after shaking this so that the sodium bicarbonate and acetic acid come in contact with each other, we will get the effervescence or a fizzy sound. We will wait till the fizzy sound ends or persists, and then we will weight the same Ziploc bag. And before doing this, before shaking this, we have to take the weight, say W1. Before the reaction, say the weight of this setup or the Ziploc bag is W1, and after the reaction, say this is the weight of this is W2. So what will be the reaction? sodium bicarbonate, this is baking soda, this will react with vinegar or acetic acid, that is CH3COOH. This gives us sodium acetate CH3COONA along with carbon dioxide. For this we will get the fizzy sound or effervescence along with water. Now this is the reactant, and these are the products. The weight of this reactant is W1 and weight of the products is W2, and we will see this W1 is equal to W2. So from this experiment as well we can prove that the law of conservation of mass is the proof of law of conservation of mass we can give from this experiment as well. Okay, now see, for few cases we may not get the expected result. Suppose for when we will burn some wood in air, that means with oxygen we will get some ash along with carbon dioxide and water. Now as carbon dioxide and this water vapor, these are volatile, so it will not stay in the same reaction mixture, in the same system, so it will vaporize or it will get mixed in the air, so we will not get the expected result. But if we do the same, if we do the reaction in a closed container, then we will get exactly the same weight of the reactant, that is wood and oxygen, and the product, that is ash, carbon dioxide and water. The same thing we can get if we burn a magnesium ribbon. When a magnesium ribbon will burn in presence of oxygen, we are going to get magnesium oxide along with heat. Now if we take only the weight of the magnesium ribbon, then after the reaction if we take the weight of magnesium oxide, then we may not get the expected result, that is W1 is equal to W2, because here we are not taking the weight of oxygen which is consumed or which is being used in this reaction. But if we do the reaction in a closed manner, in a closed container, then we will get the expected result. Okay, for today this is all. So be safe students, take care.